In this video, I want to go over the topics that are going to be covered on your first exam. This is what we did in the first module. We began with just a general definition of statistics. Started with collecting data, organizing, summarizing, analyzing, interpreting, all the different words, everything you can do with data, from collecting it to organizing it to looking at descriptive stuff and using it in a variety of ways. Anything that's data related would fall under the umbrella of statistics. We looked at actually 4 different applications. The 2 that we're going to cover this semester, the 2 that I want you to be aware of: descriptive and inferential. If you're just describing the data that you have, whether it's a graph, whether there's numbers involved, and we'll talk about some of those in a little bit, anything that involves just the group that you have, what we call the sample, that's called descriptive statistics. If you take that group you have, that sample, and then you try to make statements about a larger unknown population, that's called inferential statistics. And so the difference between these two is based upon who you're making a statement, or which group are you making a statement about. The part you have, descriptive; the whole that you don't have, that's called inferential. The other two, predictive and prescriptive statistics, for another time, for another class, you'll get there. We talked about some basic elements, some of the the basic definitions: population, sample, experimental unit. Let's go with those 3. Population is the entire set we're interested in. Sample is it's a subset of the population that we've collected information from. And then you have the experimental unit. That's the thing we measure, the object we measure to get one piece of data. The data that we're collecting on those experimental units, maybe I'm working with students, the variables that you collect are the different pieces: the height of the student, the age of the student, the year in school of the student, whether they're a full-time or a part-time student, do they work or not, all the different variables, all the different things you may be interested in concerning that student. And the variables are either numerical or not numerical. They're quantitative, QN you see listed there, or categorical, qualities, qualitative. And they fall into one of those categories. On your project, some of you have automobiles, you're working with prices, you're working with mileages, you're working with models. When you're working with the apartments and the homes, you have prices, some call them rent for the apartments. You have sizes, you have locations. 2 quantitative, 1 qualitative, regardless of the different data sets. And I use the word qualitative, categorical. It's probably a better word to use. When we do that inferential statistics, when we use the sample to make statements about the population, the only time that is valuable is if we can get a measure of reliability for those statements we make. Now, we're not going to do this as of yet. We'll get there. Module 3 is where we're going to start doing our inferential techniques. We'll look at confidence intervals and test hypothesis. But you should know that when we want reliability, we want a big number. We want to be 90%, 95, 99% confident or reliable. There are 3 different sources of data that we talked about. There's existing data, there's observational data, and then there's designed experiment type of data. So you should be familiar with those 3 different types, and when if I give you a question, you should be able to pick out which of those 3 types the data has come from. And I have to be pretty good at writing problems where you can determine that. Random sampling is pretty far down here in the list. I covered that actually in the early part of the semester, in the first week or so. It actually comes from later on in the textbook, and it's just a technique, a simple technique for guaranteeing that the sample has the best chance of looking like the population that you can. Random sample is one in which every possible combination of lowercase n experimental units has an equal chance of being selected. We then took a look at some different methods of graphing. We looked at first a frequency distribution, which is kind of a table of the results. If you're working with categorical data, there's pie charts and histograms. You won't have to draw any of these for me, but you should be able to make intelligent statements about any charts that I give you. For quantitative data, when you're working with the numbers, you still have a frequency distribution, except now the frequency distribution, rather than looking at individual values like individual GPAs or individual heights, it's grouping similar data values, similar heights, similar GPAs together into what are called classes. And then a bar graph is created for the different classes. A bar graph for quantitative data typically has the name histogram. I don't care if you use those incorrectly, or I don't even think you're using them incorrectly. You can use them interchangeably in my class. So you have a bar graph option for quantitative data. You also have a stem and leaf display. Excel doesn't give us a handy way of doing stem and leaf displays, but you should be aware of what one is, and you should be able to make intelligent statements should I present one to you. Later on in the chapter, after this is kind of the graphing data, then we talked about numerical descriptions of data, but there's another plot that I'll throw it in here. There's a box plot. And that's a plot that helps us identify outliers, which is coming up in a little bit. As far as the numerical descriptions of data, you should know about the three measures of center: mean, median, and mode. You should know what each is doing. They're each trying to measure the center a little bit differently, when one is preferred over the other. The measures of spread, I talked about three different types, but really it's a standard deviation. That's the one you need to understand. We're going to use a standard deviation. The main thing we do with standard deviations is we use the standard deviation to determine where most of our data falls. Now, where most of our data, that word most is in quotes, air quotes, depends upon what kind of data you're working with, the shape. And there were two, typically textbooks give you two different rules, Chebyshev's theorem and the empirical rule. I added the modified empirical rule. You should know all three. You should be able to work with all three rules for me this semester. You can get really specific. If I tell you you're working with one rule or the other, then you should be able to tell me the percentage of the data that fall in various places. And you've seen examples in your notes. Make sure you review those, because there'll probably be one or two questions on the exam dealing with Chebyshev and the empirical rule. And I guess I should mention the modified empirical rule. I typically don't ask those types of questions because you don't have symmetry, first and foremost, and then the numbers you see from the empirical rule are they're not really easy to grasp onto, between 60 and 90%, between 90 and 100%. It's not real easy to work those kinds of problems. But Chebyshev, the empirical rule, take a look at some of the examples I've done, because you're going to see something similar. Following all this, and all our numerical description kind of information follows. It starts with the shape, and then we get measures of center, and then we get measures of spread, and we talk about outliers. There's two different methods of detecting outliers. Outliers are those observations that we don't expect, or the ones that fall out there. And the two different methods, we have the z-score method and we have a box plot method. The box plot method is just a plot that we get from Excel or some other software program. And depending what software you use, there's a lot of different ways of presenting the outliers. Excel keeps it simple. If you see a dot, that's an outlier. If there's no dot, there's no outlier. And so it's very simple to identify outliers in Excel. For the z-score method, we're calculating a z-score for an observation and taking a look at the number. Depending on what that number is, we're going to call it an outlier. If it falls far away from the mean, say the z-score is 4, that means the observation falls 4 standard deviations above the mean, it's definitely an outlier. If it's a -1, that means it falls 1 standard deviation below the mean, that's not an outlier. And so where's the cutoff point between an outlier and not an outlier? Well, that depends. That depends on the shape of the distribution. If you're using the empirical or the modified empirical rules, empirical works for skewed distributions, and modified works for, I'm sorry, I said that wrong. The empirical works for symmetric distributions. The modified empirical works for skewed. But both those rules are telling us that most of the data fall within 2 standard deviations of the mean. So the outliers are the ones that fall outside of that. In z-score numbers, the outliers will be beyond ±2 in either direction. If you're forced to use Chebyshev, where the distribution is just weird, it can't really be described as symmetric or skewed, it's just this weird, ugly distribution, then we're going to say that we bump that out to 3 standard deviations. And so to use z-scores, we'd call an outlier something outside ±3. If we're using Chebyshev, we can bump that into ±2 if we're using the empirical or the modified empirical. Probability was the last topic that we covered in this module. And I gave you some terminology. I don't typically test the terminology all that well or all that much. However, I do expect you to be able to read a little probability table. And we looked at some or probabilities, we looked at some end probabilities, we looked at some conditional probabilities. So expect a little probability table where I give you 2 variables and I put in all the values and I ask, what's the probability of this or that? What's the probability of this and that? What's the probability of this given that that has occurred? Those kinds of probabilities. Make sure you're up to speed on probability tables. To help you, there is a sample exam. It's not here in where I'm filming now, but it will be as soon as I stop this video. It's called Cleverly the Module 1 Sample Exam. And there are 20 questions in the Module 1 Sample Exam, and I've given you some answer videos. Now, here's what I suggest. Don't just watch my videos. That's just me doing more work for you. Okay, what I expect you, or what I suggest that you do to prepare for my exam, here it is. You ready? Take a look at the examples I'm doing in my videos. Take a look at what I've covered in the lectures. That's the stuff I've spent time with. That's the stuff I found important. Take a look at those questions. Add to it now your competency check questions. Take a look at the quiz questions I've given you. Add to that now the project questions I asked. Okay, I'm going to ask your exam's going to be in multiple choice format, but take a look at the project questions because I can write those questions in multiple choice format. And then lastly, take a look at the problems I put on the syllabus in the textbook. Those are good problems too. And then when you've looked at all that, when you're like, okay, that looks pretty good, here's what I'm going to suggest. Try the sample exam. Do the sample exam without looking at the answers because the answers are at the top of it, without watching my videos. See how you do. Give yourself an hour and a half. Take that sample exam and see how you do. That's a pretty good indication of where you're at. And if you like where you're at, if you take that sample exam and you get like 95% on it, you're great. You're in a perfect spot. If you take that sample exam and you get a 70%, you're not ready. That's why you got to give yourself time. In between when you take that first exam, you want to have a couple days. So that way, if you didn't do well on the sample exam, you still can go back and review some of the material that you missed on the sample exam. That's where these answer videos come in. Now you can take a look and say, oh, I missed question 7. Let me move ahead to question 7 and see how Mark did it. And I'll talk you through it, tell you a little bit about my thinking, and it should help you prepare. But that's your best way to prepare for the exam. Now, your first exam is going to be on February. I'm pulling up the calendar here, make sure I don't misspeak. On February 7th or 8th. You get to choose. Beginning at midnight as the 6th rolls into the 7th. So as Thursday night becomes Friday morning, very early morning, that's when the exam's going to open up, and you have 48 hours until the end of the day on Saturday, until midnight Saturday, February 8th, to take the exam. Once you begin the exam, your clock starts, and you only have a set period of time to take the exam. So make sure that you're ready. Make sure you're in, I hate having to say this, but make sure you're in a secure environment. What does that mean? Make sure your power's not going to go out. Make sure your internet's steady. Usually not a problem, but it's something to consider. Sit down, open the exam, and then you go. Immediately after the exam, you'll know exactly what your score was, but you won't know what you missed. It's not until everybody's taking the exam, any makeup exams, any weird stuff's going on, then I'll open up the answers and you'll be able to see how you did or what you missed, if you missed. And then we'll be glad to answer any questions about it. But that is the material for exam 1. Hopefully you feel pretty good about that material. And when you have questions, you know how to get hold of us. There's discussion boards, there's office hours. Good luck.